In today's lesson, we're finding the area of a composite figure. A composite figure is made up of simple geometric shapes. To find the area of a composite figure or other irregular shaped figures, we're going to divide it into simple, non-overlapping figures. We're going to find the area of each simpler figure and then add the areas together to get the total area of the composite figure. So we can use this chart to review some of the most common area formulas. You can find most of these also on your star chart. When you are finding area of any shape, here are some things you have to remember. Be sure that you are showing all of your steps. Be sure that you always start with the formula that you are using for each shape. When you're finding the area of each figure, we want you to show your substitution. We want you to plug in your values. We want you to solve your area equation showing all of your work. Also, remember that your answer should be in units squared. So when we're looking at the area of a composite figure, we're going to try to divide this composite figure into two simpler shapes. So looking at it, here we have on top, we have a parallelogram. Okay, when you are looking at a parallelogram, you have to remember a parallelogram's characteristics. For example, opposite sides are congruent. So if this side is 3, this side is also 3. If this side is 10, the bottom of our parallelogram is also 10. You also have to remember things like opposite angles are congruent. On our trapezoid, we have one of the bases is 7. The other base is 10 because remember it's the same side as the opposite of our parallelogram. When you are using height in a lot of these formulas, well, the triangle and the trapezoid and the parallelogram, when you're using height, you have to know that your height is always straight up and down. Think about when you go to the doctor and they take your height, they ask you to stand up nice and straight so they can take that measurement. So a lot of times they have extra numbers that are not going to be used, okay? You have to remember that the height will always make a right angle. It's perpendicular to the base. So those are some of the things you need to know before we get started. Looking at the area of just the parallelogram, we're going to have to start with our formula, which is up here, A equals base times height. We're going to plug in our values. Our base is 10. Our height, again, will always be perpendicular, so not the 3, but it's the 1.5. We're going to multiply 10 times 1.5 for a total of 15 centimeters squared. And that's the area of our parallelogram. Now the area of the trapezoid, we need the formula, and that would be 1/2 height base 1 plus base 2. When I go plug in my values, 1/2 times my height, remember our height always has to be perpendicular to one of the bases. There's my right angle. So our height is 1.5. When you look at your bases, base 1 and base 2, I always think of base 1 as the shorter base. It doesn't really matter. So I'm going to plug in a 7. And base 2 is 10. Again, remember I pointed that out over here, that it's the same as the length of our parallelogram. So we're plugging in a 10. When you're solving your area equations, remember you still have to follow the correct order of operations. So I'm changing my fraction to 0.5 so that we could work with just decimals. And we have to follow the correct order of operations, which means I would do what's inside my parentheses first. So 7 plus 10 is 17. When you have all three numbers and they're going to be multiplied, it doesn't matter which two you multiply first. I'm going to go ahead and do these two first. And I'm going to show my work off to the side. So 1.5 has one decimal place in it, and I'm multiplying it times 0.5, which also has one decimal point. So here I have 75, but I have 2 decimal places total, so when I go put that back in, my answer is 0.75. And now I have to multiply that decimal times 17. So 0.75 times 17, that's 49 plus 1, 2, 3. That's going to be 52. Skip a space. That's 5, that's 7. When we add this up and we go put our 2 decimal places back in, we get 12 and 75 hundredths. And again, that is centimeters squared. Now that I have the area of my trapezoid and the area of my parallelogram, the last thing to do is add them up. I'm going to go ahead and write an equation for that. That's going to be 15 plus 12.75. Well, remember when you're adding decimals, don't forget to line them up. The decimal would be at the back of the 15, and we're adding that to 12.75, which ends up being 27.75, 27 and 75 hundredths centimeters, and our answer's always in units squared. So that's our final answer for our first composite figure over here. On the your turn, you're doing the exact same thing. You could divide up these two shapes into simpler shapes and then add it all together. Be sure you start with your formula, you show your plug-in, and you show all your work. Pause your video. Okay, we're going to see how you did here. On number 2, you might have split it up differently than I am going to split it up, because you could have done a trapezoid and a rectangle. I looked at it as one long rectangle with 2 triangles. So I'm going to start with my rectangle formula, length times width. Notice that from here to here is 8, but we've got to add on these 3 feet over here. So my total length of my rectangle is 11. My width is 4, so I'm doing 11 times 4. The area of my rectangle ends up being 44 feet squared. Now I have to look at my triangles. Well, I've got 2 triangles, and if you notice, this one is not the same size as this one. So you have to be careful with that. We're going to have to get 2 different areas. Half of base times height is the formula up here in the chart for area of a triangle. So if I look at this smaller triangle first, my base is 2. My height is 3. It doesn't matter which 2 you multiply first, so I'm going to multiply these 2. Okay, so that is 1/2 times 6. Well, if I take half of 6, it's the same thing as dividing by 3, because I could put 6 over 1 and just do top times top, bottom times bottom, ends up being 6 over 2. So taking half of 6, that's going to be 3. So the area of my first triangle happens to be 3 feet squared. Now I still have to get the area of my second triangle, which is just a little bit different because the base is 3 and the height is also 3. So I'm going to multiply the 2 3's together first, which is 9. And now I have to take half of 9, which happens to be 4.5 feet squared. And now I have my 3 areas, my rectangle, my small triangle, my larger triangle, and what do I have to do with all 3 of these? Add them up. I'm going to write this formula, or equation, that I'm taking 44 plus 3 plus 4.5 to get my total. Showing my work, you have to remember to line up those decimals. You can add 0 placeholders there. And you should have ended up with 51.5 feet squared for a total for this figure. On the second example, we have a square with a half circle. So we're going to start with the square formula for number 3, which happens to be side squared. The side of our square is 10. What do we know about squares? That every side is equal. So it's just side times side. So 10 times itself. 10 times 10 is 100 meters squared for my square. For my circle, we just got through with this lesson, pi r squared. So that means we don't want the whole way across the circle. We need a radius. Well, if a radius is halfway across, and you know that the whole length across is 10, then the radius must be 5. So our radius is 5 We're going to go ahead and plug in our values. It does tell us to use 3.14 for pi. So 3.14 times 5 squared. You know, using PEMDAS, we have to do the power first, evaluate our power to be 25, and then we have to go multiply pi times 25. Showing my work, I'm going to just try to squeeze that in right here. That's 27, 15, skip a space, 8, 2, 6, 0, 15, 8, 7. We have 2 decimal places in our problem total. So 1, 2, our area of our circle ends up being 78 and 50 hundredths. That was meters squared. So that was the area of the entire circle. But remember that this is not the whole circle. This is only half of it. So now that I found the area of the circle, I have to divide this by 2. So I'm going to take my 7850 and divide it by 2. Let's see, 7850 divided by 2. Bring this up. That goes 3 times, which is 6. 18, which would go 9 times exactly. When you bring down the 5, this is going to go twice, which is 4. Running out of room here, that would be a 10, which would give me a 5, and I would stop there. So this is 39.25. That's for the half circle. I'm going to take my 39.25 and I'm going to add it to my 100 for my square. So I'm going to go ahead and write this equation over here that I'm doing 100 plus 39 and 25 hundredths. So my total area, go ahead and write my answer on the line, is 139 and 25 hundredths meters squared. That's my answer for that. Okay, flip your notes over to the back. We're also going to be using area to solve problems. So in example 2, it says that a banquet room is being carpeted. Okay, so remember that carpet covers a surface. And so if we're covering a surface, that is finding area. Okay, so the floor plan of the room is shown at the right. Each unit represents 1 yard. So each of those little squares at the right represents a yard. And we need to know that the carpet costs $23 per square yard. How much is it going to cost to carpet the room? So they want us to separate this composite figure into simpler shapes. Well, we could do a parallelogram, a rectangle, and a triangle. Okay, so we're going to have to find the area of each one of those, and we have to count our units to find our dimensions. So our dimensions, remember, are our length, our width, our base, our height. So let's go ahead and find those dimensions first before we start. So on our rectangle, I am going to write sideways actually. So our width of our rectangle is 4. Our length of our rectangle is 6. The base of our parallelogram is also, well, let's see, I'm just going to write every which way. So this is 4, and the height, remember your height has to make a right angle with your base. So our height is perpendicular. Our height is actually 2. So sideways 2 for our parallelogram. Well, our triangle, our base is 1. Our height, remember, makes a right angle with our base. Our height is 2 of our triangle. So now that I have all my dimensions that I'm going to need, now I can start finding the formulas and plugging them in to find the areas of each one. So my parallelogram, this shape here, okay, it's like a slanted rectangle. The formula is base times height. I take my base, which we said was 4, and I take my height, which was 2, and I multiply those two together to get 8 yards squared. That's the area of my first shape. My rectangle is length times width. Well, my length is 6, length is usually the longer one, times width, which is 4, and 6 times 4 is going to be a total of 24 yards squared for the rectangle. My triangle is half of the base times the height, So that is going to be half of my base is 1, my height is 2. Well, I'm going to multiply these two first, so half of 2, which is 1 yard squared. I'm going to add these together, so it says to find the area of the composite figure. I'm going to write this out as a equation. That's 8 plus 24 plus 1, which is 25 and 8, 33 yards squared. Okay, well, in order to calculate the cost of the carpet, I'm going to have to multiply the area times the cost per yard, because remember the cost is per yard, and that is going to give me the total cost of my carpet. So I'm going to take my area of 33 yards squared, and I'm going to multiply it times the cost per yard, which is up here in our problem, the $23.50, to get my total. Well, I'm going to have to show my work. $23.50 times 33, that's 0, 15, 10, 7, skip a space, that's 0, 15, 10, and 7, 0, 5, 5, 7, 7. And remember that we have 2 decimal places in our problem. So when I go in 1, 2, the total cost of my carpet, this is my final answer, is $775.50. That's what the question was asking. The cost of the entire room, $775.50. Okay, in the your turn, you have a problem to solve that would involve finding area of this figure. I want you to pause your video, show all your work and all your formulas and your plugins. Okay, let's see how we did with this one. It says a window is being replaced with tinted glass. The plan at the right shows the design of the window. This time, each of our units represents 1 foot. The glass is going to cost $28 per square foot. They want to know how much it's going to cost to replace the glass, and they're telling us to use 3.14 for pi. So when you look at this shape over here, you want to get your dimensions before you start. They said that each of these was a foot, so when I find the length of my rectangle, this is 5, and that's feet. When I find the width of my rectangle, you end up getting 4 feet. Well, the width of your rectangle is actually the same as the diameter of the circle. But remember, we are finding area, which means we don't really, well, you could use the diameter, but I'd rather work with the radius. So if the whole thing is 4, then halfway across is 2 feet. So I have everything I need to go ahead and get started. Showing my work, I'm going to start with my area formula for a rectangle, which is length times width. That's going to be 5 times 4. So the area of my rectangle is 20 feet squared. That's one measurement. Now I need the area of my circle, again pi r squared. This time it's not just half a circle, it's the whole thing, so we don't have to worry about cutting it in half. That's going to be pi is 3.14. R, remember my radius is halfway across the circle from the center, so that's 2. And we're squaring it. So we have to evaluate the power first. That's 4. And we're going to have to go multiply pi times 4. So showing my work, do it up here, 3.14 times 4. That's 16, 4, 5, 12. 12.56, because I have, again, 2 decimal places in my problem. So area equals 12 and 56 hundredths feet squared. Well, I'm going to have to add this up. So to find the area of my composite figure, or the whole window, is going to be 12.56 plus 20, which is going to just be 32.56 feet squared. But the question wasn't for the area, the question was for the cost. So if it's going to cost $28 per square foot, I have to take my total feet squared and multiply it times the cost. So I'm going to multiply 32.56 times 28. That's 48, 44, 16 and 4 is 20, 26, skip a space, that's 12, 11, wait, that was 12, 10, 11, 5, 6, that's 8, 6, 1, 1, 9. And then I have 2 decimal places total, so 1, 2. That is $911.68. That's the total cost to replace the glass in our stained glass window. So this is what we're going to be working on for the next couple of days. Be sure to jot down any questions you have, and we will see you tomorrow.